Welcome back to today's session. In the previous session, we discussed a problem called all pairs shortest path. Today, we will be dealing with another problem called the max flow problem. Right? In the first problem, we considered there was a single source, and to all other nodes, we were trying to find the shortest path, which was called single source shortest path problem. In the second problem, we considered the shortest path between all the pairs of nodes. And today we will be looking into a third category of problem, which is called the max flow problem. Right? This particular problem, we solve it using a particular algorithm called augmented path algorithm or augmenting path algorithm. In few cases, in few books, you might also find another name for this algorithm called Ford-Fulkerson algorithm, right? F-O-R-D, Ford, Fulkerson, F-U-L-K-R-S-E-N, Ford-Fulkerson algorithm, right? So what is this problem all about? Before going into what is the problem and what are we trying to solve, we will try to learn or understand the background of the problem. See here, for this particular problem to be solved, we require a directed and a connected network, right? In a directed and a connected network, the flow always originates at one node called the source node and terminates at another node called the sink node. So what is this source node? A node which has all incoming arcs, outgoing arcs. None of the arcs are incoming, all the arcs are leaving the node. Then such a node is called the source node, right? At the source node, all arcs point away from the node. And what is sink then? Exact opposite. All the arcs are coming into the node. Okay? At the sink node, all the arcs point into the node. See, we have one specialized node called source and one specialized node called sink. What about the remaining nodes, all the intermediate nodes? These intermediate nodes are called transshipment nodes. Okay, we call them transshipment nodes. A flow through an arc is allowed only in the direction indicated by the arrowhead. See, we have already told it is a directed network. If it is a directed network, then the flow has to take place only in the direction which has been specified, right? And the maximum flow that can happen through that arc will be specified on the arc itself. Till now we were calling it the weight of the arc. Now in this particular problem we call it the flow or the flow capacity of the arc, right? Where the maximum amount of flow is given by the capacity of the arc. Then what is this problem all about? The objective of the problem is to maximize the total amount of flow from the source to the sink. In the network, we had a source node which has infinite capacity, and we have a sink node which has an infinite capacity. Now our basic idea is to see to it that the maximum amount of flow happens from source to sink through all these intermediate transshipment nodes. Okay. So if at all, in simple terms, if at all I have to explain it to you, let me say there are two huge tanks. One tank is called source tank, the other one is called sink tank. So the capacity of the source tank is infinite. The capacity of the sink tank is also infinite. But these tanks are connected through pipes. Your arcs, I can call it as pipes. So these pipes will have a certain diameter, right? So it has a certain capacity. It can allow certain liters of a fluid to flow through it, right? Our basic idea now is to see to it that from the source tank to the sink tank through various pipes, maximum amount of liquid will flow through within a unit time. Okay, so this is called your max flow problem. Augmenting path algorithm. The algorithm that we use for solving the max flow problem is called augmenting path algorithm. So the augmenting path algorithm is based on two concepts. One is called the residual network. The other one is called augmenting path. So we will try to understand what is this residual network and what is augmenting path. So residual network shows the remaining arc capacities after some flows have been assigned to it, so that additional flows can be assigned. Let me say there was an arc, or in our analogy we consider it to be a pipe. So let me say I have a pipe which can allow up to 5 liters, and the flow that I have assigned through it is only 3 liters. So how many more liters can it accommodate? 2 more liters, right? So that remaining 2 liters, we call it as the residual capacity. And whenever we have assigned a particular flow from source to sink and the capacity of these arcs are still remaining, then the writings or the notings of the remaining capacities of these arcs or the residual capacities of this arcs, if at all I make on a network, then such a network is called a residual network. Okay, then augmenting path. An augmenting path is a directed path from the source to the sink in the residual network, such that every arc on the path has a strictly positive residual capacity. Okay, the minimum of these residual capacities is called the residual capacity of the augmenting path, because it represents the amount of flow that can be feasibly added to the entire path. Each augmenting path provides an opportunity to further augment the flow through the original network. So once I consider a particular one single path from source to sink and I have allowed the flow, if at all I know the remaining capacities, so that I can add those arcs into another path and allow little more amount to flow through them, right? That is called each augmenting path provides an opportunity to further augment the flow through the original network. Okay, hope you have understood. So the augmenting path algorithm repeatedly selects the augmenting path and adds a flow equal to its residual capacity to that path in the original network. So we try to allow individual paths. We try to take all the possible paths one after the other, and we try to allow the flow to happen through it, and one after the other. Each of the paths will be considered. When there is no possibility left, when there is no possibility left in the network to augment any more paths, we come out of the problem, and whatever flow has taken place till then is considered to be the max flow in the problem. Clear? Hope you have understood the concept. Fine. Shall we move on to the steps involved in the problem? Steps involved in the algorithm? Right. These are the steps involved in the algorithm. First, identify an augmenting path by finding some directed path from source to sink in the network, such that every arc on this path has strictly positive residual capacity. What do you mean by strictly positive residual capacity? See, if the capacity of the pipe is 5 liters and you allow 6 liters in it, is it possible? No. What happens to the residue then? 5 minus 6 will be minus 1. So, which is not possible. That is not allowed. Right? So, therefore, we say that strictly positive residual capacity has to be maintained. See, if at all you have a arc of a capacity of 5 liters, then you can allow maximum of only 5 liters or anything less than that. Only then the residual capacities will be strictly positive. Okay? Then coming to the second step. Identify the residual capacity C star of these augmenting path, of this augmenting path, by finding the minimum of the residual capacities of the arcs on this path. Right? Increase the total flow by C star, and for the augmenting path, reduce this C star value and write only the remaining values. Okay? Once you have done with one of the paths, go back to step 1, take another path and try to solve. Fine? This is how your augmenting path algorithm works. So shall we have a look at it with respect to a problem? So this is a particular network that I have considered. See, this is the special node called source because it has only outgoing arcs and no incoming arcs. Okay? I always represent a source with S and a sink node with T. So this is your sink node. Why do I call this a sink node? Because it has only incoming arcs and no outgoing from this. Okay? So now the problem that I have in front of me is I have infinite capacity at the source and an infinite capacity at the sink. My concern is what is the maximum amount of flow that can take place between the source and sink. Okay? So shall we try to solve the problem using the augmenting algorithm or the four-person algorithm? So the first step, I will write the first augmenting path that I consider. Right? The first augmenting path that I take is from S I will move to T 2, from 2 I will go to 4, from 4 I will go to T. So from source to sink I have traveled through this path. Look at the maximum capacities of each of the arcs. So the maximum capacity here is 10, the maximum capacity here is 9, and the maximum capacity here is 10. So we call this as the bottleneck capacity. The minimum of the overall capacities of the arcs of a path is called the bottleneck capacity or minimal residual capacity, MRC. So what is the MRC in this path? It is 9 units, because from the first arc you might be able to take 10, but from there onwards it can allow only 9 liters. So if at all you have brought 10 liters, what happens to the other 1 liter? So there is no storage available in the transshipment nodes. So you cannot store anything there. So you can receive only 9 from here and allow all those 9 units to flow from here. So when the inflow to 4 is only 9, you can only allow outflow of 9. So the flow along this augmenting path is 9 from S to 2 and 9 from 2 to 4 and 9 from 4 to T. So the remaining or the residual capacities, 4 to T residual capacity is 1 and uh, residual capacity of S to 2 is 1. Okay. So now one of the augmenting paths is completed. Taken as another augmenting path. I take another path from S to 1, 1 to 3 and 3 to T. So from source to sink I have come. So look at the capacities. Here I have a capacity of 10. Here I have a capacity of 4. Here I have a capacity of 10. So what is the bottleneck capacity or the MRC? So it has to be 4. So allow 4 units to pass through it. So from S to 1, 4. From 1 to 3, 4. From 3 to T, 4. So what happens to the total flow? Earlier I had received 9. Now another 4 is coming in. So 9 plus 4, 13. 13 flows into the sink. Okay. Now update the residual capacities. Here I have a residual capacity of 6. Here no residual capacity. Here the residual capacity is 6. So there is a possibility that I can receive another 7 from the source. See, from here 6 I can take, from here 1 I can take. So let me say I will take another augmenting path from S to 1, 1 to 4, 4 to 3 and 3 to T. So look at the capacities. Here the residual capacity was 6. Here the capacity is 8. Here the capacity is 6. Here residual capacity was 6. So what is the bottleneck capacity? Obviously 6. Minimum is 6. Out of 8, 6, 6 and 6. Minimum is 6 only. So the bottleneck capacity will be 6. So allow another 6 units to pass through it. What happens to the maximum flow? It becomes 19. Earlier it was 13. So add 6 to it. It becomes 19. Right? So update the residual capacities. Here the full capacity is attained. Here the full capacity is attained. Here I have allowed 6. So 2 more can be received. Here full capacity is attained. Here full capacity is attained. But here you can allow 1 more. Right? So here, because you can allow 1 more, if at all I bring 1, where should I send it? The only outflow is this node, which is already full. So I cannot bring from here. So here inflow is 10 and it is completely satisfied. So I cannot send anything through this. Coming to this node, have a look. This is complete and this is also complete. Why this is also complete? Because there is no possible inflow to it. Though I have a residual capacity of 2, there is no possible inflow. So I cannot allow anything into it. So this also cannot be considered into an augmenting. So here capacity complete. Here I have a possibility of receiving 1. But from this inflow it is not possible. And from this inflow also we have checked it is not possible. So if from both the inflows it is not possible, I don't have a third inflow. So obviously I cannot get that 1 unit. So no more augmentings are possible. No more augmenting paths are possible. So in that case, what is the maximum flow that is possible? Whatever we had computed. 19. That itself is a max flow. Understood the problem? Isn't it simple? Right. Let us have a look at another problem here. Right? We'll take one more problem and try to solve this. Which is the source? S is the source. Which is the sink? T is the sink. And we have how many transshipment nodes? 4 transshipment nodes. 1, 2, 3 and 4. Okay. So let us try to solve it. I'll take the first augmenting path as S to 1, 1 to 3, 3 to T. So what is the bottleneck capacity? 4 to 1. Out of 4 to 1, which is minimum? 1. So bottleneck capacity is 1. So I can allow only 1 unit to flow through this network. So the residual capacity becomes 3 here, 1 here and 0 here. So no more possibilities of augmenting this particular arc. So I can only get inputs from this arc or this arc. So the flow that I have computed as of now is 1. So let us look into another augmenting path. So I take the second augmenting path, S to 1, 1 to 2, 2 to T. Okay. Here the remaining capacity was 3. Here the remaining capacity is 4. Here the remaining capacity is 3. So out of 3, 4 and 3, which is minimum? 3 is minimum. So the maximum flow that is possible through this augmented path is 3. So make a note of 3 and update the maximum flow. Earlier it was 1. 1 plus 3 becomes 4. So update the residual capacities. Here 4 was the capacity, 4 completely is utilized. Here 4 was the capacity, 3 is utilized, 1 more can be moved. Here 3 was the maximum capacity, 3 is also allowed. Okay. Next, we will take one more augmented path, which is S to 4, 4 to T. So the capacity here is 2 and the capacity here is 3. So out of 2 and 3, which is minimum? 2. So the bottleneck capacity will remain 2. So add that 2 to the maximum flow. Earlier it was 4. Add 2 to it. It became 6. So the max flow as of now is 6. Update the residual capacities. 2 was the total capacity. We have received 2. Here the capacity was 3. We have sent 2. I can receive one more. I can receive one more. So is there another source to receive one? The only source was from this arc, which is filled. So I cannot send any more from this particular path. Here, this is complete. This is also complete. So from wherever, however I receive anything, I will not be able to allow it from these two. The only possibility is from here, and for this I have no inputs. So no more augmenting paths are possible. So because no more augmenting paths are possible, whatever is the flow that I have received as of now, that itself will be the max flow. So how much flow I have received? 6. So the max flow is 6 units. Isn't the problem simple? Hope you people have understood. Thank you for your patient listening. If at all you have any doubts, you can post it on the classroom platform. Until the next session, have a nice time. Enjoy. Thank you.